Okay, perfect. Yeah, so GIS, which stands for Geographic Information Systems. And the important thing to think about here is that QGIS is a software. GIS is a approach to managing spatial data, right? So it gives you tools, it's the theory, application of managing data and analyzing spatial data. Yeah. So yeah, we'll be introducing GIS, covering concepts and theory of GIS, and then using QGIS. Yeah? So using GIS and QGIS. So what is GIS? Well, this is just a Wikipedia snapshot, which is a useful thing to do. So here, a GIS system is a system designed to capture, store, manipulate, analyze, manage, and present spatial data. Yeah. So at the moment, it's got nothing to do with software. This can be a manual process. Yeah. You can develop your own tools and methods to analyze and work with spatial data. Yeah. So many software to do this in. Yeah. So today we'll be using QGIS. I'm going to be giving a few examples later on to show you that there's other GIS software that you can use, whether it's thinking about temporal change, etc., which is better to do in different software and different programming languages. But you see here, this is just a snapshot of the different software that use GIS. So one of the most notable ones here is Google Maps. So without GIS, Google Maps is not possible. Yeah? Because Google Maps stores the kind of structure of the roads, the location of certain points of interest, and by saving that geometry and managing that spatial data properly, you can start mapping paths, etc. So Google Maps is something we can all relate to in terms of how GIS is used. So GIS and representation. So GIS represents the world or aspects of the world that the user of the data represents, right? So here we can see right at the bottom, we have the real world, which is complicated and complex and so many things that we want to know and so many things that we don't care about. Yeah. So GIS here becomes an abstraction of different layers. Yeah. So if you think of Google Maps, you have your road layer, you have your building layer. All these are different levels of information that we use to represent the real world or the parts of the real world that are important to us. So you can see here population, communication networks, hydrology, and land use as examples. Yeah. Now, a lot of when working with GIS, the most difficult thing to get started with is the technicality of it in terms of the map projections and the coordinate systems, etc. Right? So I'm gonna try to explain it in the best way possible today. But again, feel free to interrupt me because anything that I haven't clarified well will be useful for everyone else, right? Yeah. So here we're presented with a problem, right? We have a globe, which is a sphere shape. But our screens and maps are flat, right? So central to GIS is the idea of map projections, yeah? And this relates to GIS being a suite of tools and concepts, yeah? So map projection here means is how do we present the world that we're trying to analyze or look at in a 2D surface rather than a sphere. Yeah? So you can see here there's different manipulations possible. So the cylindrical one is where you take the globe and then you kind of shoot perpendicular vectors. Yeah, so it becomes you can see the edge here at the top. Yeah, this becomes perpendicular to the globe, and then it becomes a sphere, and then you flatten it out. Similar to what you'd see in Google Maps if you zoom right out, right? You see the world in a 2D surface. Yeah, but there's other ways of projecting as well. There's the conical one at the bottom. Yeah, and I'll explain later why certain projections are useful for certain things. But the thing to keep in mind right now is because we want to represent the world in a 2D surface, because at the end of the day we're going to pin up our work or present it in a portfolio, right? We have to project it somehow. Yeah, we can't just take a sphere and put it on a page. Yeah? And these are different methods. Right. So in addition to the map projections, so there's different types of map projections. They all have codes. So you can see at the bottom the two main ones which we will generally use is one called 27700, which is British grid, and the other one, which is what Google Maps use, is 4326. Yeah? So these are the two main map projections we're going to use. So think of this projection as a 2D grid, a Cartesian grid that you've created, right? How are you going to reference certain geometries and points of information on that grid? you need the coordinate system. And we're all familiar with latitude and longitude. Yeah. So latitude and longitude, if you think about it here, is just an x-axis here and the y-axis. Just flattened. Latitude and longitude are not the only coordinate systems available. There's other coordinate systems. Yeah. So I mentioned here the 27700 map projection. It uses something. It uses a different coordinate system, which is based on meters. Yeah. Whereas the one here on the bottom, 4326, the Google Maps one, uses latitude and longitude. Yeah. So you can see longitude are the ones that are going from top to bottom, and the latitude are the horizontal. Yeah. The equator is 0, and then the Greenwich line is 0 in terms of the angles. So if you go opposite to the Greenwich line, is 180 degrees. So, and then you go back, right? So hopefully all that makes sense now. In terms of the data we use, and actually I'll show this here as a quick approach. There's two types of data. Yeah, we all know what Photoshop and Illustrator is and how they're different, right? You have Photoshop that deals with the raster data, pixel data, which we have here, an image. Yeah, when you zoom in, this is actually a different image presented to you, right? So there's no increase in detail at all. It's just a different information. When you zoom out, again, it becomes less detailed, but that's because, again, that's a different image presented to you. But you can see here, it's just an image. And then the other type of data is vector data. Yeah, so polygons, so points, lines, and polygons. And you can see with the vector data, I can actually select, and they're defined very well, right? In terms of geometry, that's always present. I can zoom in and out, and they don't lose any kind of detail. Yeah, so these are the two types of data, vector and raster, when we're working with GIS. And you can see here the real world on the bottom. The vector model will separate things into lake, marsh, grassland, and the raster data will just populate it in terms of pixels, different colored pixels. Mentioned it, yeah, just mentioned it right now. So different types of vector data. On the right, you can see there's the raster example, which is just dots are represented as colored pixels, as dots. Lines are presented again as colored pixels, but they give the illusion of a line, but there's no line there effectively, right? And on the left, you have the vector data, which is actual lines, actual dots, and actual polygons. Yeah. Hello. Right. So here, in the raster image, the only data we have is the color of the pixel, right? But in the vector layers, what we can do is attach data tables to certain vector geometries. Yeah. So if I go here, again, I can't select anything in the raster because they're just pixels, it's an image. But if I go to my vector data, zoom in, I can actually select objects, and then I'll explain to you how to use all this later, but this is just to illustrate the point. I can open the attributes table, and you can see this is highlighted. So I know this is Norfolk, it has an area code here. Yeah. So the rows represent the geometry as a list. Yeah. So in this file, I have 152 polygons. Yeah. And the columns represent the attributes to that geometry. Yeah. So here, every polygon has 3 attributes: name, label, code. And you can see this is Norfolk, and this is the code for it, right? And then if you change selection, you choose Suffolk, right? So this is something available to the vector data where it's not available to the raster data, right? For obvious reasons. Okay. And again, layers and representation. So similar to what you do in Photoshop and Illustrator, everything is presented as layers. One thing to keep in mind is when you're working with vector data, you can't have different types of geometries on the same layer. Yeah. So if you have points of interest, that'll be on one layer. If you have a river, for example, which is represented by lines or a polygon, that'll be in different layers. So everything is separated into layers. Yeah. And then you just combine them as you see here. So it becomes a kind of a database where you have layers of information that represent the kind of a heterogeneous element, homogeneous element, sorry, and together they kind of explain something to us that we need to look at. So I mentioned at the beginning, GIS is not about the software, it's about the system, right? So this is a case study. So one of the early examples, this is a very popular case study in GIS, which is John Snow and cholera outbreak in London. So this is, there was a cholera outbreak in London. People were trying to figure out what the cause of this was. So John Snow had a theory. He used the scientific deductive reasoning. Yeah, my theory is because in this region I have a higher number of cholera outbreaks. I believe it's the water pump over there, because everyone's using the water pump, everyone's touching it, and then doing whatever they want to do back home, right? So what he did is he went and he mapped all the different pumps, and he mapped the cases of cholera around London. Right? And you can see, if I have Google Maps open, you can see that the pump is still there in London, right? You can actually go and visit it. And by using this system, they actually found out that the cases are clustered around one pump. Right? So then he used the system of figuring out, taking a kind of a layer, adding data to it in terms of points where things are, and then relating it to the proximity and how things are, the pumps, which pumps are closer. And then they ended up fixing the pump and fixing the issue ultimately, right? So again, this is a GIS approach in terms of using a geographic information system to manage your data and analyze your data, but it has nothing to do with QGIS. So the application here is important, and you can see this GIS, typically due to the data available, is always seen as something more international, like you would see with COVID outbreaks over the past 2 years, where they'll present the world and circles going up and down too. Yeah, but it can also be used at a local scale, yeah, household scale, the individual scale. Yeah? Just think about depending on the coordinate reference system and how many data points you use, it can be extremely accurate to 1 millimeters and even less. Yeah, so hopefully this illustrates the points of GIS and how it's useful in terms of looking at and managing and analyzing spatial data. This was my MArch dissertation a while ago now, where I also used GIS data. And this, I was looking at the city of Tripoli, Libya. And because I had access to historical maps of the city and how the city developed and land uses changed over time, I ended up mapping all these changes in land use, right? And you can see here, it goes down to the neighborhood scale, yeah? And in this map especially, there's actually specific homes highlighted, yeah? So when you have a raster image, sometimes it's difficult to work with. In some occasions, raster image is actually more useful than vector images, yeah? Well, we'll get to that later. But this process involved taking the raster images, digitizing them, so tracing all the polygons, turning it into vector data, and then analyzing things like neighborhood accessibility to schools, to hospitals, what certain master plans, how they were designed depending on the regime of the day, right? So you can see here, it has a lot of application in terms of research. And when it comes to design, it relates more to, for example, if you get into computational design, it relates to how things are placed in space and how you generate geometry, right? So I've been asked to give more examples about more neighborhood scale GIS approaches. Unfortunately, I don't have it in my presentation, but I'm going to present it from my Twitter feed just because I have it on there, right? So if I go here, just to show the different applications of GIS. So this is my research work at the moment, and I'm looking at different functions of the city and how they change over time by mapping data people produce, right? Tweets here. So tweets, understanding how people tweeting about certain places at certain times. Yeah. And this is an application where I can't really use QGIS because it's very limited in terms of managing, well, it's good in managing data, but it's limited in terms of interactivity in dealing with temporal data. Hello. So again, this is an application of GIS where you use the same principles, map projections, coordinate reference systems, you manage everything, and then you start analyzing data levels together at a neighborhood scale. Yeah? You can see, so these are points that of tweets from certain locations, and they're clustered and they're analyzed together, right? When it comes to computational generative design, this is some of the work from our CPU students. So how do you deal with geometry in space, and how do you analyze existing conditions and generate geometries from them, right? So again, GIS here for urban design becomes something extremely relevant. Yeah. Anything to do with space and dealing with kind of numeric spatial data, GIS is what you need to use over here, right? This is some of the research projects I'm working on as well on the lab. And it's an urban simulation, right? So I don't know where that noise is coming from. Okay. Huh? Oh, is it? All right. Sorry. I thought it was my computer. Okay, so yeah. So again, urban simulation. Again, I'm really showing these to illustrate the point about how GIS is relevant to neighborhood scale analysis and design, right? Because here is an urban simulation thinking about different types of taxis and the impact on autonomous vehicles in Manchester, south of Manchester. Yeah. So again, this won't be possible. You can do this in After Effects and animate dots going around, but it's not really accurate in terms of the analysis. Yeah? So again, the way the data is represented and presented allows you to do these analysis methods. Right? Otherwise, it won't be possible. This is another one a while back, looking at gentrification on the Oxford Road corridor, linking Airbnb and Zoopla listings together. So looking at how housing prices increase in relation to where Airbnb listings are presented, right? So again, I know hopefully these are useful. You can have a look at them later on, but again, to illustrate the point that GIS is not limited to QGIS, and that GIS has a lot more applications to what you'll generally see, or what we'll do today. So today is going to be a very basic workshop because I'm introducing you, right? We're not going to do this, but hopefully you get where you can go with GIS. Great. Okay. Does anyone have any questions so far? Anyone online? No? Perfect. Okay.
No, thank you.
Sorry, was that a question?
No, I said no, thank you.
Oh, okay, good. All right, great. So so what we'll do now is open QGIS. Yeah. So hopefully you have it all installed. I'm gonna delete these two layers here. Yeah. So you should have something like this, something empty with nothing in it. I'm just gonna give 4 minutes for people to open QGIS if they haven't already. Yeah, so they should be all the same. Yeah, it should be all the same. So the one, you have 2.7, so that's slightly older, but yeah. You can do this one, QGIS desktop or QGIS app. Very hot now. And once you've opened QGIS, or while QGIS is opening, I want you all to go and download some files, right? So if you have access to Teams, I've uploaded them here. So these, this one, the John Snow Clara map, this one and this one, these four, right? Don't need this one, but yeah, just this one here and these three here. Just download them to your desktop or whatever and extract these files because it's a zipped file. And if you don't have access to Teams, can you please go on this link? mmuadvanceddigitaldesign.wordpress.com. Yeah. You have access to the browser? Yeah. Sorry, how do we find them on screen? So you go on the Is that the right one? Yeah, that's fine. Yeah, that's fine. Store that link on the MMU, Advanced Digital Design, .wordpress.com. It's a lot of stuff. Yeah. Go right at the bottom. Is that the link I did? Just give me a second. Clipped. Just download the clipped one. Cool. Is everyone set up? Yeah? Right, so this is going to be interesting. I have to share the slides and the QGIS thing at the same time. So let's see how this works. Right. Okay. Right. So I'm just gonna explain briefly what the interface in QGIS is about, right? So, you know, we have the things that we're familiar with. So file, view, edit on the top. So that will be the menu bar. The toolbar is on the second row, so over here. So you can use this to move your page around, pan, zoom in and out. It's a very good idea to work with a mouse because you can use the shortcuts with your scroll wheel, zoom in and out. At the moment, we have a completely empty canvas, right? But we'll populate it in a bit. But this is where you will see all your layers. Your layers will appear here. So as we add them, you can see them here. So you might not have this at the moment, but I'm just going to show you. So you add a layer and it shows up over here. Right? And then this is where you'll view your map. Yeah. So this is where you can browse your files. So think of this as a bin where you keep all the stuff rather than opening Windows Explorer every time. You can just do it through here. On the right here, we have layer styling. So when we get into the vector data and we want to change how the vector data looks, we can change it from here. And this is where you have additional tools. I don't know if this is default. It's not, but if you go, yeah, so if you right click here, you can get these additional panels up. But that's not important for today. We're not going to be using any of these. But it's good to know that you have all these other tools that you can use, right? And this is to analyze raster analysis here, network analysis, etc. Yeah, so it's worth looking at these when you have time as well. So at the bottom on your right here, this is a very important point here. So you can see as I move around, these coordinates change. So the canvas here is not just something empty, it's actually referencing something to the real world. Yeah. So where my pointer is, so Manchester is 53 and -2, I think. So, okay, so. Okay, before I do that, let's install the plugin first. So here, okay. So similar to SketchUp, another software, there's a plugin library that you can use to download additional tools into QGIS. Yeah. So let's start by downloading the quick maps service plugin, and this will help us just bring in maps very quickly into QGIS. Yeah. So if you go on plugins, number 1, then manage and install plugins, and then you search for quick map service as a plugin. So here we go on plugins, manage and install plugins. You should get this plugins window show up here. And then you just search for quick map services. And then I have it installed already, but you should have install here as an option. You don't have quick, yeah? Okay, so this is maybe depends on the version of the software, right? But so if you go here, type in quick OSM, maybe. No, just type in OSM. Do you get anything up if you type in OpenStreetMaps? Okay, just give me a second.
Yeah, it's not giving me the options. There's something here. I want to see not like we'll figure out.
If you can download on your laptop, that'd be useful. So, so if you're using a university computer, I don't think you're able to.
I'm having the same issue. Sorry.
Yeah, you're having the same issue.
Yeah.
Are you using your personal computer?
Yeah.
Yeah. Okay. So there's nothing comes up when you do quick map services.
Yeah, and same with the OSN.
Nothing comes up with OSN. Okay. So there's a problem here in terms of your software not being able to access the online repository, right?
Yeah.
Do you have this at all on the left of the XYZ files? Do you have this?
Yeah.
Yeah. So if you drop this down and then double click on OpenStreetMap, you should get the map come up.
Okay, that works.
Does that work?
Yeah.
Perfect. Okay. So some of you will have this installed here. So it's basically an existing link to an online repository where you can just link it in. I don't think you don't have it on the, no? Okay. So the university ones don't have them. I'll bring that up with Jason. But yeah, you should get this. This should show up. Okay. So now what we can do is actually look at how this canvas presents itself, right? So at the moment, I talked about the projection system, yeah, which is here, this slide over here, the map projection, and how these are projecting differently. So we can actually go here. We have the data loaded. The data has the coordinates embedded within it, yeah. So this raster data. So if we click on the bottom right here, we can actually change the way we project that map on our canvas. So on the bottom here, you can choose the 4326, which is WGS 84, this one here, and you click apply, and you can see that the whole map's changed. Right? So we changed how we project it. And because, so just to go back to the slide, we changed it from this kind of perpendicular projection to a more parallel projection. Yeah, so the lines will go this way. That's why you see here it's more squished. And if you hover over, so Manchester's 53 minus 2. So if you go here on the bottom where it says coordinates, just over here, you can see where your mouse is and what coordinate that refers to. Yeah. So it's not an empty kind of page. It actually has the grid, the reference, the projection system embedded within it. Yeah. And we can change it here. So you have to zoom into the UK first to do this. Yeah. And then you type in the other projection, so 27700, which is the British national projection. Yeah. And click apply. Yeah. So here, the British national projection. So just search for 27700, and then you can see that the proportions of the UK here are accurate, right? Because this projection system is designed for the UK. Okay? But if we zoom out a little bit, this might even crash, right? Because it's not designed for the rest of the globe; it's just designed for the UK. Yeah. So if we take this slide, for example, you can think of it as a parallel plane to the UK, and we're projecting to the UK, so we can get accurate measurements about the UK. Yeah. But the rest of the world is going to be incredibly distorted. So you see here, yeah, on the right. So hopefully this illustrates the point. And we go here, and actually, because this is a map projection in the UK, and the coordinate systems here, the coordinate system has changed. Yeah. So you can see here it's 50,000 and 22,000. If I hover over here, and this is because this projection system uses meters. Yeah. So when you come to measuring distances, you can't measure it in the old system, the 4326, because it's not in meters, it's only in coordinates. But when you come here, this becomes a lot more accurate, right? So I can zoom in and measure this, and it tells me it's 17 kilometers wide, for example. If that's right. So I'm just going to show you what the UK national grid looks like. Here. So if we go on images, this is what the whole projection system is based on. Yeah. So you start from 0 here, 0 meters, and then you go in. Yeah. And this is what you'll find when you go on Digimaps and download stuff. Sometimes you get these funny letters, SJ, etc. This is what Digimaps is referring to. And Digimaps, the data it downloads is in the British national grid mostly.
Sorry, Mahmood, do you think you could go over the bit where you actually put the map in, because I can't seem to
Okay, the mapping. Just a second. So if you go on the plugins, manage and install plugins.
Yeah, so I've got that installed, the quick map services.
Quick map services.
Yeah.
This one. Yeah. And then I think it's here, I think it's Quick OSM. Maybe that's a different plugin, but let me go back to my page here. So if you go on web quick map services. Yeah, so this is a different tool. So if you go on web, quick map services, and then you have all these different types of maps you can download. Yeah. So.
And then OSM standard?
Yeah, you can use whichever one you want.
Okay, that's worked. Thank you.
And you can see there are different layers, right? There are different raster layers that have different types of information. This is the cycle map based on the OSM data. Yeah. So OSM stands for OpenStreetMap. It's a very popular mapping software and very popular data because it's a crowdsourced map, but it's not important for now.
Great, thank you.
Cool. Perfect. So,
sorry, what's the British projection called?
So just use 27700 here. Yeah. Okay. So if you go here, 27700. So each projection has its own ID. Yeah. Remembering the ID is easier than remembering all this stuff here. So with time, you'll just remember it. And then you click apply. Yeah. Okay. And we can change it back again to net request is timed out. Okay, so I think my QGIS is crashing. It's fine, I'll close it, I'll open it again. Right, so is everyone here okay? Caught up? Yeah? Okay, just 1 second. So okay, one thing I forgot to mention for the people downloading from the link. I don't think the people online have this issue, but just for everyone else here. So if you go on Intro to GIS, download these files, and what you want to download is the this one here, the shape file. Yeah. So the shape file is an ancient GIS file that's still around. There's a lot of memes around it, but basically it's a file made out of 4 other files. Yeah. So that's why it's always in a zip. So when you download it, unzip the file, make sure they're all staying together, the files. Yeah. Don't move them around. So don't delete the other files. Make sure they're all there. Just keep them together. Just unzip here. But this is the one you're downloading.
That wasn't as well as Teams. That was on the one on Teams.
Sorry?
That wasn't as well as what was on Teams. Or was
No. This is So if the ones on Teams, if you're downloading it from Teams, it's fine. Ignore this. If you're downloading it from the link, this is for you, right? Okay, so this is working for me. I think you need to be logged in. Are you logged into your Google account to download this? You've got it now? Yeah, perfect. Okay, good. Yeah, so this link might not work for some of you because you need to log in. So just click on this Manchester buildings with district label here, and then you can download it if you're logged in. Cool. Yeah. Okay. Right. So so the first thing, now that we've let me just load this back again. Now that we've downloaded QGIS, we've got a raster map. We know how to change this projection. We know what these coordinates mean. The next thing to do is we're going to work with 2 types of file. We're going to work with the raster file as the first exercise, and the second exercise we're going to work with vector files. Right. So the first thing to do is to install another plugin. So if you go on plugins, manage install plugin. You need a plugin called Geo Referencer. This one here. Geo Referencer, GDAL, and you can see there it enables you to reference images onto your map. Yeah. So you add geographic information to your images that way.
Where can we get it if we can't find it?
Is it not on here?
No. Also, are you sharing your screen?
Sorry?
Are you sharing your screen?
Yes. Yeah. I am sharing my screen. Is everyone seeing my screen?
Yeah, I mean, I can see it.
Yeah.
Okay. Or maybe I'll have to rejoin. Yeah, it's not when I type it in. It's not here.
It's not, sorry, what?
The Geo Referencer isn't in the plugins list.
Is it not? Okay, so maybe you already have it installed. So
on mine it says it's a core plugin.
it says it's a core. Yeah. So if you go on raster, Geo Referencer should be there if it's a core plugin. Yeah. So based on the version you're using, they change, right? But you can find a similar plugin, or you can find it. Yeah. Do you find it?
Yeah.
Yeah. Perfect. So if you can't install it, it's already there. Perfect. Okay. So yeah. So what we're going to do is we're going to take the John Snow map, which is on Teams or on the link that you downloaded. Yeah. And now we're gonna place it on the existing fabric in London, right? And to do that, we need to reference it, right? Because it's just an image at the moment. It's got no geographic information in it. Yeah. So we install the Geo Referencer here as the first step. The second step is to open the Geo Referencer and load the image. Third step. So we go here, go on raster, Geo Referencer, and then you should get this up. It's popping up. And on the top right, it says here, open raster. Yeah. So you just click on that. It asks you to locate it. So mine is over here, wherever you have it on your computer. Just go in here, and then click open. And then you should have it come up here on your map. And then your cursor will change to a kind of a cross. And with this cross, what we're gonna do now is identify the points that we want to pin geo information to, right? So think of it as a pin board. You take your image, you position it, and then you want to put the pin on the same place, right? So we can actually zoom in to London over here. Let's try looking for it. I think it's somewhere. I don't really know exactly where it is, so let's see where it is. Okay. There it is. Yeah. So look, I can see that this road here goes up, and this road here goes up. Yeah. To Oxford Street. So yeah, this is Oxford Street, and this is this square over here, right? So we can already relate this to here by eye at the moment because of the morphology that hasn't changed much. So by the way, this presentation is on Teams for you if you want to download it and follow on your screen. So here, select identifiable points and relate them to the canvas location. Yeah. So I would suggest starting with 4 points. Yeah. You can go crazy and add many points, but you don't want to go too crazy because otherwise you'll make it too complicated to work with. Yeah. So the first thing, this is an obvious one, Regent Circus. Yeah. So you just click on the middle of Regent Circus. And once you click on the middle, you should get this up. Yeah. It says enter map coordinates. So now what I've done is identified the point on my image, and now it's asking me for where the point in the map is, right? So I can do this in 2 ways. I can put the east and north. Okay, so let's cancel this. I want to change this back to, just because it'll be easier to work with the longitude and latitude because you're aware. Just change this. Change this back to 4326. So close it, apply. Okay. You can do it either way, to be honest. It's not, but just because of latitude and longitude, it's easier to work with, maybe. Yeah, it's fine. You don't have to do this. Just keep it as is. Okay. So here we go back again. Select the middle of Oxford Circuit. So we have 2 options. We can select from canvas, or we can actually input the data in here. Yeah. So I'm going to do is select from canvas, then go to here and click. Yeah. And then type OK. And now you can see there's a red dot. Yeah. And then I have this row over here, which tells me in my image, I have the references 154, minus 183. So this is the coordinate of this on the image, and then the destination. Yeah, right. Yeah, and you can see the red dot comes up here as well. Let's see. I can also add a different point. So I think this one's a good point to go with. Here. I can hover over here, right? And just copy and paste that coordinate on the bottom into the boxes. Or I can go from canvas. From canvas is easy. We're not trying to be super accurate today, just to show you how to use it. So from canvas, and let's see where this goes. So I believe this is here. So this is Bond Street. Yeah, so this is New Bond Street, so it's the same one. So here, New Bond Street, and this corner here. And then I click OK, and you can see that I have a second point. If you mistakenly put a point and you want to redo it again, just right-click, remove, and then you can remove it, and then you add another one again. Yeah. So go back here from canvas, and then this one here. Here. Okay. Is everything clear? Yeah? No? So have you loaded your image onto the of the Google Drive? Okay, we'll worry about that later.
Have you got access to Teams? That's all the part of Teams.
Yeah, and yeah, we just need 2 more points. So identify the other points you want to add. So here, this is a Soho Square is an obvious one. So I can just go in the center of Soho Square, here and here. And then just one more because the 4 will make sense. Otherwise, it'll interpret this corner in a funny way. Yeah.
So you have to make it sort of square. We can do that before.
Yeah. So 4 in a row won't work. Yeah, because imagine it work if you're referencing a line. Yeah, but the image it won't understand where this goes, right? So if you pin it to the edges, it's always the best thing to do. You can also manipulate it in the middle. So if you pin it to the edges and the center is slightly off because of the drawing might be off, you can actually move it and it'll distort the image. If that makes sense. So I think if you play around with it, you'll know what I mean. Right. So let's see. So here. What did I use here? Okay, so I can use this point here. There. Is that the best one to use? This is a trial and error, by the way. So sometimes you might find a point that you put in the wrong place, so just delete it and do it again. There's no right way of doing this. It's just trial and error. Yeah, so I think this is fine here. If I choose this, and then here. Yeah. And once you have 4 points that you're happy with, you click on this play button. Yeah. This play button, it will take your image, distort it based on the points you gave it. Yeah. And then this is where you figure out please set transformation type. Okay, so we'll do that from here. Source, destination. Yeah, so I know these are lat long, right? So I want to change this target SRS to the same one as this one, right? Because I'm using the geographic information from my map, so I can't give this a different system, right? I need to give it the same system. So here I just go down and give it the same one as I have here. Otherwise, my map will show up somewhere else on the globe. Yeah.
How did you pull up that tab? Sorry.
Yeah, so settings here. So once you click play, it should just pop up. If not, just go on the settings. Yeah, this gear on here. Yeah, just keep everything else fine. The output raster is where you want to save it. Yeah, and you can see here the output is a TIFF file. So TIFF is another format for geo. Is another raster format that can also contain geographic information. So one thing to keep in mind here, that the layers I have in my QGIS application, they work in the same way as InDesign would work. So they reference a file rather than them being stored in my file. Yeah, does that make sense? So everything I create, everything I save, always has to be saved on my computer, and I have to reference it in my images. So that's why it's asking me to save the file somewhere. Yeah? So if I save it here, just to wherever you save your files, QGIS tutorial, save. Keep all this fine. You should see the settings here. Yeah, so projective, same as project CRS. This is important. Specify location, so where you want to save the raster, and load into QGIS when done. Yeah. So here, if I don't tick this, it'll just save it and forget about it. But here I'm asking it to save and then load back into my layers. And click OK. So now I should run again. And then you should have something like this. Which is clearly wrong. I've referenced one of the points wrong. Yeah. So you can see how the points here are really important. And this is a typical way when you're working with archival data. Yeah. Because the maps have changed. Everything has changed. So you need to be very careful with them. But to figure out how I've done it wrong, so we'll troubleshoot now. So we'll go on. We'll select our image. Remember, this is saved somewhere on my computer, right? So I'll select here. And then on this second tab here, I can reduce the opacity. Yeah. And then I can see, okay, so Soho Square, this looks fine. It's referenced in the right place. Regent Square, again, that looks fine. This looks fine here, but this is, I've done something wrong here, right, with this corner. So that's why working with the corners is very important. So I'm gonna do this again, and figure out where I've gone wrong exactly, because this needs to, I think it's actually this point. Maybe not, but okay, let's try this again. So I'll go on Geo Raster. I know these two are fine, so what I'll do is I'm going to keep that one. I'm going to get rid of this one, so remove. And I'm going to get rid of this one. Yeah. So that was a good one. That was a good point, actually. I got rid of the wrong one. I want to get rid of this one. Remove, reference again. So go here, region from map. There. Okay. I can get rid of this one, so I can just do remove layer. So I'm not deleting it. I'm just saying remove the reference from my computer because I'm working with a new one, right? So here. Okay, this time I want to reference the curve here, right? So I'll go here. I'm gonna reference region circle here. Piccadilly Circus. Map roughly here. Okay. Yeah. So we can try. I can try with 3 now. Okay, so it's telling me 3 points are not enough. I need more points. Let's go back again. Maybe this one over here. Yeah. Here. Okay. And then let's see how that looks like. Yeah, that looks better. That looks good. So I can reduce again, and you can see that my roads are lining up now, right? Here. Yeah, so if I zoom in, this is a new road, by the way, clearly. This is, for those of you familiar, Piccadilly Circus, Oxford Circus, and this is Regent Roads. And all these roads are pathfind. So this is how I'd reference kind of archival material and see how the layers have changed and the city has changed over time, right? Because putting them over each other is a lot easier to compare in more detail how it's changed. So now let's do some kind of analysis, basic analysis of the map. And the way we'll do this is by creating a vector layer. Yeah. So now we're taking the raster layer and we put it in QGIS. Now I want to create a vector layer. So what I can do here is go on layer, create layer, new shapefile layer. So I'll give it a name. I'm going to call it pumps. Encoding, we can leave where that is. I mentioned at the beginning, we can either have point, line, or polygon, right? So because I'm identifying the location of pumps, I'm going to use a point because location is useful here. The projection system, I want to keep it to the same. Yeah. Fields, this is not important for now. I'll explain what these are later. Yeah. So by the way, I need to save it to a location. So just click on these three dots and then save it to wherever you want to save it. Yeah. So I'll just bring it here. I want to save it over here. So the name is pumps.shp. Yeah. So shp stands for shapefile. And then I click save and then OK. And then you should have a new layer come up here, which is pumps. It's got a dot next to it, which tells me it's a line. It's a point type layer. And then the toggle box next to it. Yeah. So if I go to the attributes table, so I showed you this earlier, right? So each object in my layer is a row, and the columns are attributes of the object. At the moment, you can see it's completely empty because I don't have anything in my layer, right? I've just made a new empty layer. So again, this is a layer that I've saved somewhere. So anything I do in QGIS, and then when I click save, it's going to save it to the file I just saved. Yeah. So references in. So to add points and add data here, where I go is go on this button. So toggle edit, and this enables me to edit the layer. Right. I click on toggle edit, and then I get these options here. Yeah. And this is with the point. This is the icon I want. So because it's a point layer, I want to add points to show where the pumps are. Yeah. So I click on add point layer, and then the cursor changes, and then I can start identifying where the pumps are. Yeah. So so if I go on here, sorry, where is it? There. Just going to show you the map. So if you zoom into the map, see that in this map there's the location of the pumps are identified, right? So I got a pump here, I got a pump over here, I got a pump over here, I got a pump over here. So now I can start mapping them. So go here. I can add this as a point. Yeah. And I can give it ID. So I'll just give it a 001. Enter. Yeah. So now I'm creating my own data, vector data layer. So here, that's one. That's my other one, 002. Enter. This is the infamous pump just over there. So I can go back here and select it. 003. 004. You can actually turn the layer underneath off if that helps you, right? That's going to help out a lot actually. So pump 005. And now if I go back on my attributes table, these are the points I'm making. Yeah. Now this is a similar thing when you go on websites. You can download data like when you go on Digimaps and you download building topology. This is how it's actually made out of polygons, drawn, and then added more attributes here. Or if you go on the crime data, it shows you the location of crimes and the types of crimes. It's a similar thing. Yeah, so you don't have to add them all. You just need a few, especially around this area where the pump is. So there's one on top here. There. 006. Yeah. So now we're creating our own layer, and if we turn this off, turn this on, we can see that okay. Now we're actually identifying exactly where these pumps were. They're probably not there yet, apart from this one in the middle, but the rest are. Yeah. Position pump and add points, add attributes. So what we can do here is, since we have our rows, we can add a field, yeah, or an attribute. So I mentioned earlier that we have the object, which is the vector object, and then we can add a table to it, right? So here I'm adding a new column to the table. So I can click on add attribute. I can name it location, for example. Yeah. I need to specify the type of data I'm going to be putting inside the attribute. Yeah. So I'll put text for now, but if I put numbers, I can use that numbers later on for analysis, right? So numbers, and then click OK. And now I have this new column that I can add more data into, right? So I'm not familiar with the area, so I don't know what these different areas are, but London EC1. Let's see. Imagine that's a postcode. Yeah. So, and then you can add more information. Yeah. It's very important that once you finish, or while you're doing this, make sure you save the data as you go. So just click on toggle again and save. See, so it's crashed. That's great. So I should have saved it earlier. That's a shame. But I should have my image saved, so it'll be good. It'll be useful to show you how this works actually now. So if I go back here, I have the JPEG. I have my TIFF. I can just bring this in, and it's back to where it is, right? Because I geo-referenced it and saved it earlier. Yeah, so it already has the geometric information in, and the shapefile I can do the same. I can just drag it here. Yeah, so I have no data, so because it crashed before I saved it. Lucky me. And then I can add these here again, right? So just gonna go quickly, add a few points. So go and edit. This might be useful to do again actually. So here, pump. I actually have one. So I already have the points actually. Okay, good. So no data lost. Yeah. So just make sure you save. Yeah. Everyone clear?
I have a question. Can you
Sorry, what was that? Sorry.
Oh yeah, so I have a question because
Yep.
we need to save very often, as you said. Is
Yep.
there an option like Revit to remind us, for example, every like 20 or 30 minutes to save, like an auto save message, or no?
Not that I'm aware of, no.
Okay,
Not that I'm
that's
aware of.
all. Thank you.
No. So just make sure you save often. Maybe there is something, but I'm not aware of it, to be honest.
Okay, thank you.
So QGIS is an open source software, so it's actually built by many people. It's not hasn't got a monopoly, so that's why it's free and accessible, and people make all these plugins for it. But sometimes it can be glitchy, so just make sure you save your stuff. Any other questions online?
Hi, can you hear me?
Yes.
I was wondering, how did you get the window with all 6 points open?
The
Before you,
window with all 6 points.
yeah, where you could name the points.
This one. Or this one. Oh, okay. So the attributes table here. This one. So make sure you're on your vector layer. Go on the attributes. Click on this, and then you get up.
Wait, sorry, where's the attributes?
So it's on the top here. So if you go on the top bar where you have the icons,
Uh-huh.
it's roughly in the middle of the icons, middle right, and
Oh,
there's
yeah.
an open attribute table. Yeah.
Yeah.
And this is where you can add so many different attributes. You can add the color, the size, the manufacturer, the whatever, right?
Thank you.
Okay. So just 1 second. I want to see a few people here.
You're right. I can't get it to. Is it one thing? Yeah. Just put some points on there. It takes time to refine it, so I'm not expecting everyone to do it. Yeah. So let's say the points. Yeah, can you say it again? Use the points.
So, sorry, I've been messing around with the.
Okay.
Yeah. So, if I want to make a vector layer now.
Yeah. So you go on vector. Yeah. Create layer. Initial part. And use this. I don't want to see it. And judge. Good. No, I got lost and I did. Which is easy. Yeah, that's fine. Have you tried referencing it? I don't even know what that means. Just click on there. Oh, yeah, I did that. So, how many points do you want more? Cool, I have a lot. So, but you get the idea, right? You get the idea? Not really. So you're actually taking this, imagine this is something that you can scratch. And you just making sure you pin it everywhere. So actually distorting it. That's why I'm getting, you see how it's distorted. Yeah, that's because I'm pinning it on the second. The idea is to take a just random. So when that does 16, it should come up as I have it there. Yeah, that's fine. Just you can't get 2 points in like Are you okay there? Are you okay? Okay. So there's an online on YouTube. I'll show you now. Just go on YouTube. This is it makes videos of a lot of people. I can find pages to go to.
So for the people who've kind of have gone too fast or they're struggling with the software, I suggest you also look at the MSA ADD YouTube channel. So this is something we created last year. If you go playlists, you can find tutorials for all the software you need effectively, right? And I should have QGIS. Yeah, so here, ADD 3.5 GIS. I have 4 videos on there. You can have a look at again later on or refollow, but you can. I'm explaining the same things effectively, right? And there's an exercise there as well. I'm not sure the same exercise is on there, but there's a different exercise. So have a look. Just go on the MSA ADD channel. Right. Cool. So now that we have some points, you see there's a lot more points, but I'm just going to work with the points that I have at the moment. What I can do is start to generate new information or analyze these points. Yeah. So I can go to the vector geometry tools, Voronoi polygons. So GIS here, vector. These are some of the tools I can do to manipulate my geometry and analyze them. Geometry tools. Voronoi polygons. Yeah. So and it gives you a short explanation here. So this algorithm takes the points layer and generates a polygon layer containing the Voronoi polygons corresponding to those input points. So Voronoi polygons in this case will show us the catchment area, so to speak. Yeah. So which area of this neighborhood is closer to which pump? Yeah. And you can see it over here. So this kind of pattern we're trying to generate. So we just look at the setting, the input layer, pumps. Yep, that's fine. And then, of course, as always, we need to specify where we want to save the output to, because the data is not within our software, it's saved somewhere else. So you can click here, save to file. I'm saving all my files in this folder here, so I'm just going to save them there. And I'm just gonna call it pump Voronoi.shp. Save. And then if I run, and it runs correctly, I should get something like this out. So I'll do that again. So I'll remove this. I'll remove this layer. I go on vector, geometry tools, Voronoi polygons, pump. This is an offset to the boundary, so I can give it a percentage of extent. So if I give it 100, it'll double in size roughly, just to give me more buffer. So I'm just going to give it 100. Run again, and you can see it's slightly bigger, right? And if I turn the opacity down a bit here, you can see that this pump here is actually where it's giving me an actual boundary, a catchment area for the actual outbreaks. Yeah, cases. So this becomes an analysis tool in our case. Yeah. Sorry? It crashed. Yeah, so make sure you save it. The good thing about QGIS, if it crashes, because you saved all your files, you should just load them back in, right? The problem is when you haven't saved the file, then you have to do it again, unfortunately. Okay. Do you have any questions online at all? Yeah, I haven't been keeping an eye on the comments, so I'm not sure if anything's come through. No? Okay, cool. So what we can do is we'll take 10 minutes break, so I can see some of the people around here. If anyone online has a problem, let me know as well. I'll help you figure it out in the meantime. Yeah. But for the rest of you who are following, we'll just we can just take a 10-minute break if you want. Yeah. So 11:40 we'll carry on.
20 minutes later.
Right, okay, so let's carry on. So just a few things that I've noticed. Saving your layers is different from saving your QGIS file, right? So your QGIS file, all it has is reference to these information, yeah? So when you click save here, I'm saving my composition of all the layers together. Yeah, does that make sense? Exactly, okay. So on the desktop here, I'm just gonna call it QGIS file. So next time I open that QGIS file, it'll load and link to all these and bring them in, yeah? But saving my layers is something different. So I can go here, delete something, yeah? And then I click on this one, save layer edits. Now that's saving the edits to my layer, yeah? So the file that I saved as, where I exported the polygons, that will be edited. So if I bring this layer into another project, it will come up like this. So hopefully that's clear. I know there's a lot of, it's a different software, right? It doesn't work like the other softwares, but these are the things that we need to make sure we know so that we can work with the software properly. Okay, so a few of you have asked me over here how to draw the boundary. So same thing, you go on view, you go on layer, create layer, new shapefile layer, and this time we create a polygon layer. Yeah. So typically polygon are for areas or boundaries. Lines are for stuff like roads where it doesn't have to close, and points are for things that we want to show locations for. Yeah. So we go on polygons and then save this as just poly.shp. Okay, and now I have a new empty polygon, and you can see the icon here is a square, right? Rather than a dot, and this tells me it's a polygon. And the same thing again, I go to edit layer, and then I can add polygon feature. And here now I can draw the boundary. So I'm just clicking on the edges there, like this. Yeah. And then right click, give it a ID, and now I have my boundary. And then if I click on the edit thing again, it's asking me, do you want to save the edits to the layer? Yes, because I've added a new geometry, I want to save it. Yeah. Again, so this one saves my layers together as a file, and this one here, when I edit the layer and save the edits to the layer, is something different. Okay, so yeah, so again with the layer styling, I can change this here, right? So with the fill, I can change the color of the fill, apply, can make it an orange. Similarly, what you'll have in Illustrator. Here, I can have it cross-hatched. Yeah, so hopefully you can see these orange hatches here. Yeah. My outline layer, I can my boundary, the actual boundary, I can change as well. And I can change the thicknesses of those as well. Right? So it gives me a lot of flexibility in terms of how I style it as well.
How do you save it once it's true? I've got that. How do I like?
Yeah. So once you've drawn your polygon, just click on the toggle editing again. And then it prompts you to save. Or actually, rather than making a mistake and saying no, just click on this here. The save icon for my layer edits are here, and the save icon for my projects here. Yeah, so there's two save icons. And you can see how this is useful if you have a site and you want to draw additional polygons on it or whatever, or edit your site, your topography map might, or your site DWG map might have changed and you want to change a building. So you just bring it into QGIS and change it around, and then that's it. You're sorted. Right. Okay. So now we're going to jump into a new exercise, and this one I want to show you how to. So you've all downloaded the files on Teams. These are files accessible on the internet, so you can search for if you're looking at crime, for example, I know there's a file on crime. It shows you the location of crimes and where the types of crimes that have been committed in Manchester or any other city. So you can download it as a shape file, and you can download it as other formats that QGIS can read. Right? So, hello. Have you got any questions over here? No? Wow, someone speaking. Right. Where was I? Okay, so now. Is it just me or can someone hear something? Right. So loading files. So I can turn these off for now. Yeah. You can just keep this. So there's two ways I can actually go on layers, add layer, add vector layer. Yeah. And I can locate the files. So these are the files I uploaded on Teams. Yeah, for you to download. So you can actually locate it from here. And an easier way to do it is just to drag it, right? Just take it here, drag it into your layers panel. Yeah. So this is a shape file that shows me all the counties, I think, in the UK. Yeah. Again, I know this is on a UK scale, but scale here doesn't matter, right? I'm just showing you how to use. You can do this easily on a neighborhood scale where you're looking at lampposts or whatever, right? But this is on a UK scale. But the application is the same. Yeah, so you can just drag and drop. Again, so we're working with shape files. So shape files have these different files associated with them. Yeah. DBF, I think this is the attributes data. Yeah, so that's why you need it with your shapefile. PRG is your projection. So this contains the geometry, but this contains how the geometry is presented geographically. Yeah. So all these files work together. But all I need to drag is the shapefile, and the rest is sorted out, right? So just put in the shapefile, and the rest is automatically generated. So you can see this is just one example of something I found online. Download the zip and just put it in straight in. Yeah.
Sorry, I was wondering where do you get those files? Is it from a particular website or?
Yeah, so it's you search for them. So Digimaps is one of them. You can download a lot of GIS.
Oh, okay.
Yeah. If you go on the government website, so the link here, you actually have to search for them. So there's actually maps for GM. This is actually a good website. GM Open Data Infrastructure Map. This is a very good website for you to have a look at. I think it's done here in the University of Manchester, by the way. So if you go view the map, it actually has a lot of GIS data in many layers about Manchester. Yeah? So mapping gm.org.uk. Yeah, and this is just a collection of a lot of many different resources brought together. Right. So this actually let's spend a bit of time here. So you can see these are administration boundaries mostly. Communication, so broadband strength. Yeah. Broadband strength across Manchester. Culture and heritage, you can look at listed buildings.
Is this website only for Manchester?
No, it's an open website. Anyone can go on it. Yeah. I think so, because it says mapping GM. I don't know who made the website. And also here, I think University of Manchester, if I'm not mistaken. But it's mostly focused on Manchester, where you can find data on other stuff as well. National trusts, polygons, gardens, environment and ecology. So you can see the amount of data available here, right? Not everything is useful, but you're bound to something. You're definitely going to find something useful. Yeah. Flood zones. Flood zone 2 and 3. Agriculture classification. So if we zoom out, it tells you which areas are urban, which areas are suburban, which areas are kind of agricultural, etc. Yeah. Housing. Yeah, and you can see the different vector types, right? So we have polygons here to identify areas, and we have other. So these are points to identify certain locations of stuff. Yeah. So listed buildings is points. Cool. So hopefully that answers your question, Molly. Yeah. But you can. It's just about researching, finding out. Okay. So crime shapefile. Can't even spell today. Shapefile UK. Yeah. Crime map. Police.com. I go there. Statistics. Download area crime data. Yeah. That's how you do it.
Right, thank you.
So yeah, this is how this is a government website where it has all the words in, so it's very useful to get. Sometimes you have to make your own data, right? So similar to the example I gave earlier with my old dissertation, I took the raster, geo-referenced it, similar to what we did earlier, and then I drew polygons, many hundreds of polygons. Yeah. So I'm making my own data, and then I can analyze it using proximity calculations, etc. So yeah, you won't find the perfect data. Sometimes you have to manipulate it. Sometimes you have to make it up, as in create it, not just make it up. Cool. So we have these polygons. I just want to show you how to manipulate some of them, right? So for example, if we want the outline of Greater Manchester, what do we do? Yeah. So if you go on the layer and you click on this icon over here, yeah, you can actually start selecting features. Yeah. So I'm going to select these features, and you all know why. So this is the Greater Manchester region, yeah. And I've opened the attributes table. You can see like, okay, this is the city of Manchester. So this is the attributes already provided with the data for me, right? So I haven't inputted any of these. These are already there. But I can see Stockport, Rochdale, Wigan, Trafford, Manchester. I'm selecting all these: Salford, Tameside, Bolton. I'm selecting all these, yeah, city regions. Yeah, this one here at the top. It says select features by area. Or I can go down the list and select them from here, right? Well, that doesn't make sense. It's going to take ages. I can just select it from the map and then look at the attributes. I'm just going to open the windows because it's getting really hot in here. Just 1 second. All right, never mind. So yeah. Perfect. See you later. So click on the features, select the city boundaries that fall in the Greater Manchester region. We can see the attributes. Yeah. So here on the right, select inverse. So again, it's one of the options I have for selection, right? So where is select inverse exactly? Number 4. Okay, yeah. So if I go here, on the top here, it says invert selection. Yeah. So I'm selecting the areas I want. Invert selection will select them all apart from the areas I want. Yeah. I need to be in edit mode because I can't delete anything if I'm on the layer mode. So edit, and you can see it's highlighted in red now, right? And then I press on delete. Yes. And then I get rid of all the other stuff that I don't need. Yeah. So this is what I mean in terms of manipulating the data that you find online, right? Is that clear? Do you want me to repeat that? go through again, yeah? Okay, so you should all have this layer. Yeah. So you can go on the select features by area. I can select all my relevant areas here. Open the attributes table. So this one here, F6 is the shortcut. If you keep on clicking on the icon, you'll get many open here, right? So just be careful you don't open many, then it'll crash. And because I've selected here, it's highlighting the ones I've selected over here. Yeah? I can click on this, which is select inverse. So I'll select everything I didn't have selected. Yeah? And then I can just press delete on my keyboard. So go back on QGIS, delete. Before I delete, again, it's telling me here I need to be in edit mode. So go in edit mode first, delete, yes, and now I got rid of all of them. And then I can save it if I want over here. But this will override the data that I downloaded, remember, right? Yeah. So again, because they're geometries, I can pretty much do. I can do geometry manipulation similar to what I'll do in Illustrator. Yeah. So in this case, I want to get the boundary of Greater Manchester. What I can do is select them all. I don't even have to select actually. I can just go on Vector, Geo Processing Tools, Dissolve. So dissolve. If the geometries are overlapping or adjacent, they'll just make it into one, right? So my polygons, I need to choose where to save it. Yeah. So at the moment, you can create something called a temporary layer. So I'm not giving it a location. I'm just clicking run. Yeah. So a temporary layer, you see this kind of chip on the top. And this tells me it's not saved anywhere on my computer. So if this crashes now, there's no way I can recover it. Yeah. So a temporary layer is useful when you're trying to explore whether something works or not. But it's always good practice to save your files and delete them later rather than not save them and then lose them. Yeah. So if it's temporary file, right click, export. Yeah. Save features as, and then you save it to a location in your laptop. Yeah. So this is just an exercise trying out different operations. So I can load my other data. So let's see what I have here. England wards. The wards, England ward 2011 clipped shapefile, and then just drag it in. Yeah. And similar thing. This is giving me wards rather than city boundaries. Right? And you can see it's a bigger file, so it's taking time to load. This time it becomes a bit tricky, right? So we can go select every single ward in Greater Manchester, but because we have this polygon already, we can use this polygon to select rather than select everything by hand. Wards. So wards are, you can think of them as neighborhoods. Yeah. So Hume is a ward. They have their own MP or whatever. They elect someone for them, and then yeah, it's a political boundary thing. But you have cities and then wards, and then so wards make up the cities. Right. So yeah, these are wards, and if you select on them, again, so I think this is city center. I can do this to move selection up. So city center, Manchester. Okay. So yeah, so here, select vector geoprocessing tools intersection. So I'm just showing you a few of the things you can do to manipulate vector geometry, right? So vector geoprocessing intersection. Everything's in here. So the input, the overlay layer, is this one. The dissolved one is the input layer, right? So this dissolved is what we just did the dissolve operation on. Yeah. So you just go here, dissolved, and over here these are my wards. Yeah, WA 2011 wards. I'm going to save this to a temporary file as well. I might regret it later if it crashes, but just to save some time at the end for Q&A. Yeah? So we run. So this is looking at your ward polygons and which ones fall within my boundary and getting rid of the rest. Yeah. Is it finished? Yeah, so algorithm finished. So this is my debug close. Let's see what happens. Yeah. So there you are. This is my new layer intersection, right? So these are all my wards in Manchester. You won't find a file online, for example, that gives you only the wards in Greater Manchester. So this is how you deal with it. Cool. Any questions at this point, online or in person?
Not like ultra related to this specific thing, but I've tried intersecting some files before, and they were taking like insanely long. It was saying it was going to take like years to finish. Do you know of any like easy way to speed up intersecting or clipping things?
So it depends on your files, Cameron. So I don't think that's a problem with GIS, QGIS. I think that's a problem that some of the files you have might contain unnecessary amount of detail.
Okay.
So what you can do is you can actually simplify layers, so make them simpler geometries, and then you can do the intersection operation.
Okay.
Another more complicated and more advanced technique is to use a database management system, which is more efficient, but that requires coding, etc. Right? But in the first instance, I would make sure your geometries are simplified. Yeah, so you can find tools online on QGIS, and then try and stick it together.
Okay, I'll try that.
Cool. Do you have any questions over here? No?
Just the last bit. I've got everything working.
The intersection. Yeah. So just to go over the intersection again. So I'll get rid of this file. Remove layer. Okay. So I have all my wards in the UK. Yeah. And I have my dissolved layer, which is my Greater Manchester region. Yeah. So I go on vector, geoprocessing, intersection. Yeah. You can read it here. Basically, it only shows you the intersecting polygons. Yeah. Input layer, it's very important, the order here, right? So I need to give this the dissolved, which is my Greater Manchester boundary first. And my second one is my wards. That's all I need to do, and then run. Yeah. And then you should get this as an output. Right. Then again, I can go back here. Remember my projection here. I can change this to 277, 2770, and here that's a more accurate representation, right? This is how I view my canvas here. But the data itself has its own projection embedded within it. Yeah, but that's more complicated. Just yeah. So at the moment we have the wards. We came up with them using the geo processing tools. We created a new polygon. Yeah. So now what we can do is by ward count how many buildings are in each ward. Yeah. As a analysis that we're doing for Greater Manchester. So we go here. We need to bring in the layer which is called Buildings Greater Manchester or something similar. GM Buildings. Yeah, bring in my shapefile. Make sure you save it before you bring it in because it's a heavy file. And this file is an outline of all the buildings in Greater Manchester. And you can see how QGIS is very efficient in terms of dealing with the amount of data. If you do something like this in AutoCAD or Illustrator, it's gone. So it's a very, very efficient tool for you to use. You can zoom in and see all these buildings, right? So I can do it. This is actually relevant to the point before. I forgot your name who asked the questions, but I can do intersection and count how many polygons are in a polygon. But that's going to cause me some problems because sometimes the building might overlap, right? Because the data is not perfect, or because the building in real world does overlap for some reason. So what I'm going to do is going to generate a point for each building, and because of the insane level of detail I can go in with vector geometries, that I know that point will never be in between the boundaries. Right?
Is it gonna count like each separate building, even if it's like a shared?
Even if it's a? Yeah. So, okay. So maybe counting each building is the wrong thing to say. Exactly. So it's going to count each polygon here that represents a building. If it's a small polygon, it'll count it as a building. If it's a big polygon that's a terraced house, it's going to count as one building. Yeah. But that's things you need to think about when you're dealing with data like this, right?
Way to program it to count a polygon to a certain area.
Yeah. Yeah. You can do that. So if you go here, right-click, filter. I'm not going to do this now, but you can actually filter. So, okay, so the data doesn't have an area attribute. So the first thing I need to do is run an area calculation on each polygon. It'll give me an area attribute for each polygon. Then I can filter it here. So I can see area larger than 4 meters squared. I count as a building. The rest, ignore. Yeah? So it gives me a lot of really good tools for analysis. Okay, so here, vector, I think analysis tools or geometry tools. Research tools. Random points inside polygon. Yeah, this one. So my input layer is all the buildings. Sampling strategy is point count. Let me see. Let me just make sure I don't want to random points in polygon vector. Sorry. Yeah. So I don't know why I said random point. Let's just do a centroid. That makes more sense. I don't know why I'm doing random point. Yeah. So vector, geometry. Geometry tools, centroid. It's the same thing. Centroid is more accurate, perhaps. So here, Greater Manchester, and then run. Yeah, so this is calculating the centroid for each polygon I have in my GM_buildings file. Let's give it 20 seconds or so. You can see it's telling me it's having issues with some of the polygons, right? So some of the polygons might be self-intersecting, etc., but we'll ignore this for now. Yeah. There we are. Close, and now we can see, look, if you zoom in, this is considered one building, and these small ones here are considered one building. Right. So it's flawed, it's not accurate, but demonstrating the tool and the application of it is useful here, right? So I see here. This tool. Yeah, so we go on vector, geometry tool, centroids. And these are basic operations, right? So if you want to count how many points in a polygon, you'll find this easily in QGIS, right? So we can go here, vector, analysis tools, count points in polygon. I give it my wards because I want to count how many points are in a wards. My centroids, yeah, that's fine. That's fine. Count field name. So I'll show you what this means. I'm just going to call it counts. Yeah. you don't have to rename it. I just want to show you how this is going to be relevant later. So count and run. Yeah, so you can see this is a slower operation. 3%, 4%. You don't all have to do it if it takes time, but it's counting. It's going to count a lot faster than we can count it. Let me show you that. It doesn't want to. It's probably you put one of the settings wrong.
Yeah, I haven't said anything.
What was it saying? Basically, it's failing because there's errors. So if you're having a problem with the centroid, it's because the I don't know if I can actually show you now because it's actually loading. Yeah, I can't. Oh, actually, I can. Perfect. So if I go on settings, options, processing, general, invalid feature filtering, just change it to ignore features. So the reason it's failing is because I mentioned that some of the polygons might not be accurate or they might be self-intersecting. And basically it's stopping and saying, okay, I'm not doing this anymore. But you just tell it to ignore. So I should basically there's some polygons that's not likely. You just have to ignore that. Stop executing the now just do you have any questions online? So while this processes. No? Cool. Just give it a couple of minutes then. Finish.
Yeah, has that fixed it? We fixed it. Yeah. Simple Google. Yeah. That makes it. Yeah, so you find this as well as structure. So did you follow this exercise? So this is the next stage. Just download these and then so all they can say now. This recording is going to be on YouTube. Yes. This is basically me saying this is the real one. This is the data. Google Maps. You go on a road, it's a line, right? In reality, it's not a line. So you use the line to represent. Down the street map. Go on Digital Maps has so many building maps. Yes, all. Yeah. Okay. Right. So I just had a question I think is worth sharing with everyone else. Oh, I think I actually did the wrong commands. Crap. Okay. So I actually used the whole UK words. That's wrong, right? Because I just want the words that I created here. So I used the wrong layer. Okay? But here what I'll do is just go on geoprocessing again, intersection. Okay. Okay. So this it's crashed again because I used the wrong file. Has anyone done it successfully over here? Counted the buildings? Yeah?
The other weird thing is that in some words I've got 0 buildings at all, and they don't even show up in underneath there.
Okay.
But it's like just few of them.
Yeah, okay, so I'll have to do this again, unfortunately, because it's crashed. It's my fault, so I'll do it quickly again. That's why you should save your files and not keep them as temporary ones. But we're nearly done with the exercise. Just two more steps. Okay, so actually saved it here. You can see they don't hold any data. So I need to get rid of these layers. Remove layers. Okay. Yep. So here Gonna do this quickly again. So vector, geometry, dissolve, run. So this is my dissolved. I'm going to use these as intersections. So vector, geometry, intersection, dissolved. This is fine. Run. Okay. So here I can actually save these files, right? So if I go, I can click on wherever file I produce, go and export, save feature as. I can save it as a shapefile, so the same file I used to drop in, or I can save it as other stuff like DXF, which is AutoCAD compatible. GeoJSON, this is another popular one, but more for coding. Yeah. But if you know you're going to bring it back into shapefile, into QGIS, I think shapefile is suitable. Otherwise, you can, if you want to take it into AutoCAD, you can do this. Yeah. So shapefile, I'm just going to save this so I don't have to do it all over again later. Manchester wards.sh. Okay. Okay, so now I need to get the buildings again. So here, Greater Manchester buildings. And now I want to make sure I do this right. So vector, geometry, no, analysis, count points. Oh, I need to generate points first. So vector, centroids, run. Here. So again, I can save as. Building, centroids. Okay. Now, layer analysis, count points in polygon. So here, I want to use wards, Manchester wards, and the points is the centroids. And then I can run. I can see it's a lot faster because I was counting it for every ward in the UK, but now I'm just counting it for the wards in Manchester, right? Take care. Perfect. Okay. So now it's giving me polygons, right? But it's actually successfully completed the operation, right? Because if I go on the counts, go on the attributes table. If I go right to the end here, it's count. It's added this. So it doesn't make sense for it to create. What's the count geometry going to look like, right? It doesn't make sense. So it actually created the count attributes. So it's counted how many buildings are in each polygon and made a new attribute of the number of buildings in that polygon. Yeah. So now I can, at the moment it's not I can't really visualize it, right? But if I go here on the right, layer styling, my count layer, I have different options to visualize. Yeah. So I can do graduated here. It's turned off because I need to give it a column. So graduated will take an attribute and stylize based on that column. Yeah. So I can't stylize using text. I can stylize using a number because it has a range. If I type in count, apply. Count. These all off for now for a second. Here, count, method, color, classes. I need to click on this classify. Yeah. And now, based on the reds, so here's by the way, white means, so you can see here, values from 0 to 790 buildings, yeah? And it goes down here, right? So let me move this down like this. So you can see I have 1, 2, 3, 4, 5. I have 5 categories, and it's changed these kind of bins in capture. Yeah? So you can see how the attributes now is used for the analysis as well, in terms of visualization and using it, spatial data to drive this analysis. And this is what I have here as well at the end. So that's the end of both of our exercises. Well, hopefully you've learned something useful. Right. If you have any questions related to your project, I'll be happy to answer. Yeah. So we have half an hour maybe. So yeah. So on the YouTube ADD channel in the QGIS playlist, I actually show how you take these maps and plot them to scale. Yeah. So we don't really have time now, I think, but later on you can have a look at that if you want. Yeah. So the ADD YouTube channel. But you can see how it's all about managing the data, making sure all the numbers work, all the operations I put in the right layers, otherwise they'll crash. I'm just saving them. Do you have any questions online? That's all? No? Any questions over here? Applications, projects, are you thinking about something in your project that I can help you out with or something?
I just got a question about the last thing you did.
Yeah, sure.
I'm just on how you want me graduating. All my values coming up with like 1.
Did you do the count? Have you got the count attributes?
Like the table?
Yeah, the table.
I can get it, yeah. So maybe I missed that. That's the count idea. Yeah.
So if we don't have questions, we can call it a day. Yeah. Anyone online? No.
Yeah, thank you.
Okay. Thank you very much.
Thank
I think
you.
no problem. If you have any further questions, I think the ADD drop-in sessions are useful. So about QGIS. Yeah. So this video is recorded, so it'll be uploaded somewhere for you to wherever Jason decides to put it, right? But it'll be saved here definitely on the Teams chat. Okay. So hope you have a good day, everyone. See you later.
Thank you.
Thank you.
Bye.
Thank you.
Thank you.
Thank you.